Hi everybody, hope you're having a great Friday off. Thanks for watching this little video and finishing our function basics worksheet so that on Wednesday we can all be on the same page. So if you want to find that in your notes, we will go ahead and get started. Okay, so our first question says refer to the task above, or the task on the front side of the paper, and it asks what is the value of f of 2? Describe how you determined this value and describe 2 additional methods for determining this value. So looking at our example here, we notice that just as we talked about, there are 4 different ways that this one function is being described: as a story, in a table, in a graph, and with a algorithm or expression. So pause the video. And how would you figure out the value of f of 2 using one of these methods? Okay, so now that you've had a second, remember that f of 2 says that my input, my x value is 2. In terms of our problem, that's going to be x is the number of days that this banana is in a store. So we're thinking about 2 days after the banana has been in the store. F of 2 is going to be the y value, or the function value, and that's going to tell us how much the bananas cost in dollars per pound. So I'm going to talk about all 3 ways that you could have determined what f of 2 was based upon the information that we're given. So first, we could have used our table. Since x is our input, x is our independent variable, x is the number of days. I can look on my table where x equals 2 and go over to the y column and notice that when x equals 2, when the number of days past, or the number of days that the banana has been in the store is 2, the cost of the banana in dollars per pound is $1.50. So hopefully you found the answer of $1.50 when you pause the video. Now let's move to the graph. How could we figure out what f of 2 is, what the function value at x equals 2 might be? Well, we could go over on our x-axis to 2 days that the banana's been in the store and go up until we hit our function, until we find that function value, that y, and notice that it also has a value of 1.5, or $1.50 per pound. And the third way that we could do this would be to use the formula that's given at the bottom of the page. We could, instead of an x, plug the 2 in for x, because that's what it's asking us to find, the value of the bananas in terms of dollars per pound 2 days after bananas have been sitting in the store. So then with some simplification, so notice all 3 methods resulted in the same answer. After 2 days of being in the store, the bananas will cost $1.50 per pound. Okay, moving on to number 2, we have refer to the example above, so still dealing with bananas. Explain the meaning of the mathematical expression f of 5 equals 0.75 in relation to the story. So I want to highlight this term mathematical expression because you'll see it again, we'll use it often, it'll be on your homework. So when you see that, know that we're referring to an expression that tells us information about the input and the output. It'll look in this form. But what we're trying to do is go the opposite direction. We're trying to be given a mathematical expression to write some information that we know in relation to the story problem. So to write an English sentence instead. So let's deconstruct this mathematical expression. So we have this 5 here. we know that the 5 is the input, the 5 is the x value. So we want to ask ourselves, what's the units on the 5? 5 what? Well, from the example in the front, the x is the number of days that the banana is in the store. So x, or 5 in this case, is number of days in the store. All right, so what else do we know? We know that f of 5, or the function value, is 0.75. That's the y, that's the output. So let's go find the unit 0.5 what in relation to this problem. So if we flip back to the front, the unit on the y-axis is price in dollars per pound. Okay, so we have all of the information. Let's put it together in one nicely worded English sentence. So we could say 5 days after being in the grocery store, the bananas will cost 75 cents per pound. So that's the English sentence that goes along with this mathematical expression. Okay, problem 3. So we have the population of a city, P, in millions is a function of T, the number of years since 1970. So P equals F of T. Write a mathematical expression that represents the given statement. In the year 1982, the city has a population of 12 million people. So, in problem 2, we went from a mathematical expression to an English sentence. This problem, we're flipping that order. So pause the video and see if you can't write a mathematical expression that matches the last statement. Okay, now that you've taken a second to think about this one on your own, let's work through it together. So let's kind of deconstruct what's going on here. So we've got this P equals F of T. The description tells me that P is the population, the number of people in millions. And then we have F of T. Well, we know that T represents the number of years since 1970. And we want to somehow deal with the numbers 1982 and 12 million. So the city has a population of 12 million people. That's going to be our function value. That's the population of the city in a specific year. That's this P term. So we know it's going to be 12 equals. And then the function, we've got to figure out what is our input. What's our T? And at first, you might be thinking, oh, it's 1982. But be careful, this problem was trying to trick you. because t is the number of years since 1970. So if we put 1982 as our t, as our input variable, that would mean that, 1,982 years after 1970 was the year that this was happening. So that's not what we're talking about. So what I'm going to do is to figure out how many years since 1970 1982 is, I'll subtract them. So my input is 12. 1982 is 12 years after 1970. So this is my mathematical expression to match the English sentence. In the year 1982, the city has a population of 12 million people. All right, moving along here, we got to number 4. So we're given a formula and we're asked to fill in the table. I'll do one with you, and then I want you to pause the video and finish the rest of them yourself. So let's start with x equals -2. So that means that -2 is our input, and we're looking for the function value of f of x at x equals -2. So what I want to do is everywhere that I see an x, replace it with -2. And then let's do some simplification. So the function value of my formula at x equals -2 is -13. I would love you to pause the video and fill out the rest of this table. Now that you've had a second to fill in the rest of the table, double check your answers. And if you are tech savvy, feel free to find solutions like this using your calculator. Maybe you have a graphing calculator that you like, or maybe you just want to do it by hand. Either way, some practice solving some problems is good. So let's move on to number 5. We're almost done. There we go. Just like the dot cam. Gotta figure out if you can see what I'm writing. Okay, number 5 says use the table below to create a graphical representation of the data using an appropriate scale and make sure to label your axes. So I've got a table, I've got some x's and some y's, some inputs and some outputs. So let's draw a graph. Just my basic 2 XY axes. I only drew the positive quadrant because I noticed that all of my numbers were positive. At this point, I'd love for you to pause the video and determine what scales you want to put on the X and the Y axis. Because this can be the trickiest part of graphing, is deciding how many numbers should one hash mark count for on each axis. So take a second and see if you can't create some number scales for each of your axes. Okay, so I chose to make my largest x value 10, because that was the largest x value in my table, and I also chose to increase by increments of 1, because I have all whole numbers. Although you could have gone up by 2 because they're evens. There's no incorrect way. Okay. There are many correct ways to graph a function. on my y-axis, or my f of x axis. I also went up to 10, again for the same reasons. 10 was the largest y value, the largest function value, and they were all whole numbers, so I decided to go up by ones. Okay, so now we want to plot each of our points. I'll plot the first one with you, and then I want you to pause the video and finish the rest of them. So let's start with this x equals 0, f of x equals 5. Remember, this means that we have to run or go into the elevator 0 steps. So we're going to remain at the origin, and then our elevator is going to take us up 5 floors, or the function value is 5. So we're going to go up 5. So there's our first point. Go ahead and pause this video and plot the rest of your points. Okay, so after plotting everything, your graph should look something like this. Now, I didn't connect the dots because the data that we're given looks like it's discontinuous. We don't have a data point for 7 or 6.2. However, as the front of the page says, we can still represent a function that's discontinuous with a formula, but you're not asked to do that in this problem. I just thought I would point it out there. Also, how could you convince yourself that this table and this graph actually represent functions? Is there a way you could test to see if it was a function or was not a function? Think about it. Maybe jot an idea down to the side. I'd love to see some responses when I collect and look at these on Wednesday. But moving on, last question. Last question. Yep, we're good. Says, consider any function f of x. Represent this function via a mathematical expression, a table, a graph, and in words. Use the example on page 1 as a guide for creating these representations. The order in which you choose to create these does not matter, but make sure that your representations are consistent. So what this question is asking. Take a look back at our banana story problem and get creative and make your own story problem. Create your own situation. Come up with a table that represents your situation. Graph your table. And then see if you can't find a formula that also represents your situation. If you want to work with a partner, I'm more than happy to have that happen. But get creative and see if you can create your own story. The one that I ended up making was talking about putting money into a piggy bank. But you can do whatever you want. Okay, once you have finished creating your own function, representing it in 4 different ways, you are done with this assignment. Turn it in to your instructor on Wednesday and have a great long weekend. Thanks for watching.